Well, thank you so much. And it's really great to be here. Thanks for the organizers for inviting me. You don't know what kind of trouble you're going to get yourself into, as usual. It's a great conference. I really, really enjoyed it. Actually, as it comes to those interdisciplinary conferences, I think you've done a really great job. So let me ruin it for you. Oh, I lost my... That's so very strange. Okay. Anyway, there was a big trigger warning there. When it comes to interdisciplinarity, I think it's really important to actually talk about the social contract that different disciplines have and the integrity of the disciplines that we operate under. Now, in the introduction, thanks so much for this kind introduction, I think you failed to mention I'm a professor of contestable design at the Royal College of Arts in London, and this is something that there's no social contract for. I see it as a license to be a troublemaker. And I got into the habit in the last few months to actually shout at middle-aged white men as part of this contract. I'm not going to do it today, but I'm going to acknowledge the fact that as a middle-aged, middle-class white man, the only thing I can provide you is trouble. Okay? So let's take it from there. So even someone like Yuval Harari recognized the fact that we are now entering a time where none of our current systems are actually available to deal with. Yeah? So he says, we have inherited the current political system, whether communism or liberal democracy, from the Industrial Revolution, and I don't think that's him, but I agree with him in this context, that either of them can survive the completely different realities of biotechnology and artificial intelligence. And I think it's not a coincidence that those kind of conferences are happening now when we're trying to make sense of what's going on. Now, the problem is that actually the decisions we're going to make, especially when it comes to life, which is my bias, are driven by systems that are not really compatible with the knowledge we have. So for example, as Jonathan Foyer says, factory farming, but in this sense, every engagement with living systems is consider nature as an obstacle to be overcome. Now this is a really interesting case because obviously it's not just our current engagement with living systems. I think communism for many iterations was thinking about the idea of nature as, or nature itself as something that exists outside of humans as an obstacle to be overcome. The neoliberals definitely see it. I see it, but I see the concept of nature as an obstacle that we need to come to terms with. I believe, and I hope that Latour and people like Tim Morton agrees with me, that the idea of nature as a construct, it's a metaphysical construct that is not very helpful in us making decisions in regard to how we're engaging with the world outside of us. So I try to avoid the use of the term nature, but in this context, the nature is a traditional way that I suppose most of you would relate to it, something that is outside of us that we need to somehow fix or see as an obstacle that we need to somehow overcome. And many of the talks we heard today, some of them are really hopeful and have all of those promises. The basis of the logic that drives them is this idea that this is some kind of an obstacle that we need to go through. So as the conference and as we, I'm sure, recognized it throughout those last 2 days, if not before, it's obvious that technology is becoming more lifelike at the very same time that life is becoming more technology-like, and we heard about it. So in a sense, we allow our technology more autonomy at the very same time that we try to impose our control over so-called autonomous systems, so systems that exist outside of our control. Now, I would argue that as a benchmark, by definition, any attempt to assert one wills over another autonomous system is by definition an act of violence. And we heard that yesterday as well. So in a sense, we have to acknowledge the fact that our engagement with the world is based on violence. And it's up to us to make the choice of what level of violence we're willing to engage with. Now I promise I won't say anything about Zionism, so I'm not saying anything about the existence of you in this place, but obviously it's kind of hopefully resonant. So to do with white men, this person here, which we heard about him before, Craig Venter, the guy who was involved with the Private Human Genome Project, which was basically a sales exercise for sequencers, and we heard about sequencers before as well, also did this thing which we heard about yesterday. Actually, we heard about the different experiment he did, but he did an experiment in 2010 where he claimed to develop the first organism that one of his parents is an organism. A computer, sorry, thank you. And this is Yonat, by the way, my collaborator. what's interesting with that, on quite a lot of very different levels, there's a really interesting anecdote. He was trying to find an organism that has a very small genome. And those organisms usually are parasites because they don't really need all of the other mechanisms. They rely on other organisms to operate for them. The first life form that one of his parents is a computer, the first life form that actually cut the whole chain of DNA replication, in a sense, because that DNA of these organisms was sequenced as we had, was an organism called Mycoplasma genitalia, which is a parasite that affects the human and the primate male and makes them scratch their balls. So here's like a little piece of trivia for you in regard to the type of godlike qualities of the type of first creature that the computer decided to, or that Craig Venter decided the computer would sequence. Now, what's interesting with Craig Venter, that he's like the most extreme anti-vitalist, yeah? And he believes in DNA. He's a DNA chauvinist, and as I demonstrate shortly. So this is from a review of his book, Life in the Speed of Light, where he basically talks that from his perspective, any attempts to assert any importance to anything outside of DNA within the context of a living system is basically a form of neo-vitalism. Yeah? So basically, from his perspective, there's only one thing which is important, and we kind of heard some nuances around that in the last couple of days, that there's only one important thing within the context of life, and that's this information replication system of the DNA and nothing else. Now, that allows someone like Venter to say, and as we heard as well, I can empty a cell from its DNA, put a new DNA, reboot it, and create life. Now, forgetting about all of the other systems that operate within the larger context of the cell. Yeah? So there's no DNA, for example, that codes for cell membrane. But that doesn't matter because DNA is the important thing, so we forget about all of the other things. There's no DNA for so many other parts which are part of the mechanisms of what makes life what it is. Now, I would argue that in 100 years' time, people would look back at us and they would basically look at us as the same way we look back at the 17th century with the idea of the Eumeculus. The problem is DNA is the only thing that the male contributes. And therefore, this is where the focus lies. Everything around it, the milieu, the context, the cell, the membrane, everything else doesn't exist in the eyes of the DNA chauvinist. All right, so keep that in mind. So United and myself started to develop this type of language to try and describe what we're dealing with, and we talk about the idea of neo-lifism. And neo-lifism is a sort of fetishization of technological approaches to life. So in the eyes of the neo-lifist, the biological milieu is transformed into an abstracted technological instrument of control, where life is just another raw material to be engineered. Decontextualized life has been reconfigured, mixed and remixed, reappropriated and instrumentalized to such an extent that the technologically imagined potential of life stands for life itself. And I think we've seen it in a few of the talks throughout a couple of days, but in general. Now, if we are not fetishizing DNA, we're fetishizing other artifacts that we kind of would like to recognize. So you can go to the Science Museum in London, and once in a while they pull it out from the Wellcome collection. Dolly's shit. So you can go and worship Dolly's shit as a way of acknowledging this technological breakthrough. So we need to find all of those objects of fetishization. But you are not going to see the 277 other attempts to clone a ship that were unsuccessful. Yeah? So the narratives are kind of strange. Anyway, in 1996, I was a very different man. And I was optimist then. I think I was younger. I didn't reach the middle age. So I wrote a thesis in my product design where I was trying to imagine a future in which biotechnology and design might come together. 20 years later, this dream became a nightmare, and it's actually happening. But it gave me, and Yonat, who joined me, enough time to think about those issues, because we decided to continue this research as artists rather than designers, because we felt that the ontological breaches and the problems that are associated with this idea of designing living biological materials in such a way needs to be addressed in different ways, so without promising anything useful. Our technology of choice was something that just emerged at the time called technology called tissue engineering, which we felt would bring about a much more interesting a nuanced discussion around our relationship to life than if we would go towards molecular biology, for example. Another decision we made was to kind of avoid the human, although the next few slides use the human as a model, but from our perspective, this is just another biological body. But what's interesting, this is actually a slide that I picked up from a presentation that one of the pioneers of the field of tissue engineering, Dr. Joseph McCanty, who hosted United myself as research fellows in his lab back in 2000, used for his presentation. I think it was the second or the third international meeting of tissue engineers back in the year 2000, appropriately in Disney World in Orlando. But what he was trying to show is this major conceptual shift in our understanding of bodies that occurred in the 90s. So this image is from 1989. This is how we imagine we're going to repair our body or replace injured or missing body parts. Exactly 10 years later, 1999, the body seems to be like a site that repairs itself. Yeah? So the idea was to somehow use those regenerative powers or those latent regenerative powers of our biological body in order to kind of be able to regrow body parts. And that was the basis of tissue engineering and what's known now as regenerative medicine. So the idea, the promise was to create new organs, either by using stem cells or by cloning, therapeutic cloning. But the very original concept of tissue engineering was very simple, and as artists we could relate to it quite well. You start with a three-dimensional biodegradable polymer scaffold in the shape of the organ you're trying to replace. You seed it with the appropriate cells of the organ. You grow it in vitro outside of the body for a while. You implant it into the body, and you have a new organ. And that was the promise. How many of you think that there are actually organs that have been grown in such a way in bodies, in human bodies?
It is working.
Sorry?
It is working.
It is? All right. The only thing that's working are bladders and skin. Yeah, the very simple, thin
Cartilage.
and cartridge, although there's issues with cartridge, which I'll show shortly. From our perspective, the idea was forget about the body. How about using this technology in order to create what United and myself started to refer to as semi-living entities? We set up this tissue culture and art project in 1996 to continue exploring it. We developed serious projects, and I'll just run shortly through a few of them. This is our pig wings project. This piece is actually on permanent display at the Museum of Modern Art in New York, which is kind of appropriate for the idea of disappointment. That work was basically commenting around the whole idea of genohype, this idea of, and the hype surrounding technologies, but that one in particular was originally commissioned for a celebration of the so-called completion of the first draft of the Human Genome Project back in the year 2000, which was actually a political stunt in order to get the media off the back, because the public Human Genome Project was lagging behind the private one that was led by Greg Venter that I showed before. We decided to look at some of the rhetoric and said, okay, if pigs could fly, or if one of the things that was mentioned there, that now when the Human Genome Project is complete, which it wasn't, the impossible is possible, and we said, okay, so pigs could fly, so we wanted to see what shape the wings would take. And we looked at the three evolutionary solution of flight invertebrates, the bats, the birds, and the pterodactyls, and said, okay, in Western iconography, they're usually associated, they have a value, so bat wings are usually attached to devils and demons, bird wings are attached to angels, and pterodactyl wings, we still have to figure out, because we just found out about them late in our history, so we kind of color-coded them and said, this is kind of the three ways we can also relate to what those new technologies can bring about. And what we've done, we basically, funny enough, we used 3D printing, but we were not really celebrating it because for us it was just a tool and not a hype machine. And that's back in the year 2000. We 3D kind of designed the wings in 3D, printed them out, used the bone marrow stem cells from a pig, and we then cultured them for about 9 months. And we ended up with those small bony structures in those shapes of the three evolutionary solution of flight invertebrates. We also showed them live in the gallery, so we had a bioreactor where we would show another sets of wings, which were alive. We would feed them every day, but we also would kill them by the end of the show. Now, interesting enough, so I suppose I should tell you that the organization that commissioned us originally to present this work hated it. And it's so beautiful to get a genuine rejection letter where you know that you really touched the nerve, because one of the lines in that letter of rejection said that we didn't represent the public opinion in regard to the Human Genome Project through this project, which is a very strange thing to ask artists to do. Yeah? And the other thing is they mentioned that this project lack any artistic or scientific merits, which is kind of good to know as well. We should tell the MoMA as well. But what we found out that when we started showing it, the same kind of hyperbole rhetoric was used in order to try and promote this work. And the curators, to some extent, also were sure that if we're not doing flying pigs, and I've seen a presentation by a scholar that found a photoshopped image of pigs with wings and claimed that we've done it. But if not flying pigs, at least we would tissue engineer wings which are big enough for pigs to fly with. But we ended up with those tiny structures that we presented in those cheap jewelry boxes. So we started to kind of talk about this idea of the aesthetics of disappointment, because from our perspective, and this is where the contestable comes into as well, our idea is that we decided, but it's not really our contract with you, but as artists we decided to actually do what we claim we're doing. And it can get quite disappointing when you see all of the speculative projects and all of those promises that are coming out of this field of the so-called bio-artists. There's some really strange things coming out, and many of them, and again, artists have a license not to tell you the truth, are less disappointing but less truthful. This is, I suppose, one of our best-known projects. We've grown a small piece of leather and then we decided to grow it in the shape of a jacket. The first version was shown in 2004, where we co-cultured mouse and human cells to create this tiny jacket, but also from our perspective it was really important to show this life support system that we use in order to grow the cells. We use the same kind of system, so a polymer structure on which we seeded cells and they were maintained alive in the system. We were invited to this really optimistic design show in MoMA called Design Elastic Mind, where out of the about 250 works that were there, this was the only living thing. And as far as I know, this is the first time since Edward Steichen in 1936 that kind of a living artwork was presented in MoMA. But 5 weeks through the show, it had to be turned off. This is kind of something that never happened to us before. We're using mouse embryonic stem cells, and they sheared off the polymer structure and traveled throughout the system and clogged the system to such an extent that, in this case, life grew out of control and took over its life support. And Paolo Antoinelli, the curator, was really cool and started to kind of play around it and play with the discourse, including talking about the idea of pro-life and pre-choice within the context of America in 2008, which was a really brave move. And obviously the media had a field day, so we also had the New York Times headline. But that was MoMA Kills Art. And from our perspective, it was one of the most successful interventions because of the context of this optimistic design show that was supposed to show what happens when you get artists and designers to work with science and technologists, and we're going to fix all of the problems of the world. And the only living thing that was there, this tiny jacket made out of mouse cells, will have to be killed 5 weeks into the show, and generated a much more interesting discussion around where we're going and the responsibilities that we have to exercise when we deal with life. Now, we heard a little bit about in vitro meat. I'll show you a short video about how we did our in vitro meat. Apparently, we were the first to grow a piece of meat and the first to eat it. And just watch this video.
At the University of Western Australia, a strange creation has been slowly growing in a lab. Oron Catts works in the Biological Sciences department, and he's been making some of the world's first artificial meat.
When we grow those cells, we actually tend to refer to them, we coin the term semi-living, because they're not fully alive, they're not an animal, but they are a living part of an animal sustained in an artificial environment.
This artificial meat was grown from animal muscle cells. Cell cultures were formed in a microgravity bioreactor, a machine which rotates, evening out gravity. Without it, the meat would be a film just a few cells thick. Oron is now looking for ways of giving the meat more texture.
Research which is being taken place at the moment in trying to find ways in which you can exercise those muscle cells so they would align and have a more of a muscle-like texture. And there's two ways that can be done. One is by electrically stimulating those cells, or the second way is to try and exercise them physically, trying to build tiny exercise machines, tiny gyms for those cells to grow and become more like muscle.
We've brought this unique piece of engineered meat to the UK, to one of the world's greatest chefs. With 3 Michelin stars, Heston Blumenthal is famous for his fusion of science and gastronomy. This meat is so novel that here in the UK it's not recognised as food, so it can't be cooked or eaten.
It reminds me of something.
What does it remind you of? Let's smell.
Liver. Smells of raw liver.
I mean, the texture is more like liver than it is meat, isn't it?
Okay,
It's like a baby.
basically, there's another issue there, which is not just exercising the cells, but also the fact that you need to feed the cells. And I'll talk very shortly about it. This is the first time we ate it. It was in France in 2003. I won't have time. The good thing was that out of the 6 people who joined us for dinner, 3 of them spat them out, so we could collect them and show them in the follow-up exhibition, The Remains of Disembodied Cuisine, where you have the bits that were spat out with the video documentation of the process. But something we need to remember, after 2009, where Mark Post, this Dutch scientist, claimed that he's going to grow a piece of burger and get Heston Blumenthal to grow it for him, I decided, actually, I need to come back to it. So I started those meat performances using a secret ingredient, and that's fetal calf serum. So this is what you need in order to grow those cells, and don't let anyone tell you differently. You know, there's still no alternatives for that. And again, it's a challenge. If there's anyone here who's connected to those people that claim that they can grow meat without it, let me test it, because it's not happening yet. So you still have to kill animals in order to grow this so-called victimless meat. Sorry. This is Mark Post. This is the Dutch guy that claimed to grow and eat the first burger that was funded by, funny enough, Sergey Brin from Google. And he was cooking with the fetal calf serum, and after that he called me and said the PR people actually told me never to work with you ever again. So another white man off the list. Right, that's another white man which I won't have time to talk about, because I want to talk to you about, actually I won't talk to you about that. I'll finish with this project. This is our latest project of Jonathan and myself in collaboration with Mike Bianco. So we started to look at this idea of care since the very beginning of our research. So from our perspective, when you start to work with living biological systems, you need to figure out also issues around what you do with them. So as I mentioned, we developed those feeding rituals. We would feed our sculptures whenever they needed, or as a performative kind of ritual of maintenance and care. We would kill our sculptures also as an act of care, but also as a conversation around the outcomes of this kind of relationship that one has, this violence that I mentioned at the beginning, that need to be acknowledged. Because what Western technology seems to be doing better and better, and we had this conversation around the robots and the drones, for example, is not eliminating the victims of our existence, it's hiding them. And we need less and less TED Talks and more people actually telling us how fucked we are. Okay, so this is our job. But then we started to kind of this idea of, and this is where my pseudo-utilitarian title about the biologization of industry versus the industrialization of biology. So, if we acknowledge the fact, as I said at the beginning, that by all of our attempts to engage with life are both attempts to control as well as kind of leftovers from the logic of the Industrial Revolution, there's no worse example of that than the field of synthetic biology, which is driven by engineers. They're trying to impose 19th century's ideas about industry onto biological systems. Now, that's not going to happen. So we need to start to think about, this is, if there's any glimmer of hope, is we might, and we had a little bit about it through the biomimicry, although I don't think that those people pushed it far enough, we might have to learn how biological systems operate, real biological systems, how they operate out there in the real world, not in this idealized nature that we all kind of fantasize about, and figure out if we can work with that. So the project that Jonathan and myself did is also kind of an homage to Donna Haraway, and the idea of Donna Haraway says, I'm a compostist, not a posthumanist, so maybe you should change your posthumanist salon to the compostist salon. And from our perspective, it's the idea that we're composition, and we heard about the microbiome and stuff like that, but it's also the idea of compost, the idea that we always rot, but by rotting we are becoming food for some other things. So we developed this compost incubator. Like literally, we put a pile of shit inside this device here, and the heat that was generated through the activity of the microorganisms was then used in order to, symbolically in this sense, it was in Japan, we had some issues with they didn't let us put anything living there, although the bacteria inside the compost was alive. But there's a small petri dish there that theoretically you can use as an incubator, and you don't need, you need electricity to the pump, and to actually the first cybernetic device ever to be invented, and that's the thermostat, which is actually the first time humans relinquish control to a mechanical system, which is interesting enough for caring for other life forms as well. But we also had a beehive incubator. So we basically, the beehive is an incubator. The bees are really good in maintaining homeostatic conditions inside the hive. And we developed a system where the bees were basically keeping the environment for one of the tissue flasks over there in constant conditions that were, so it's upside down. But funny enough, also we had a wasp attack about 3 days into the show. Most of the bees died and ended up in the compost pile, warming up nicely. Just one little point. Yeah, we had chemistry 101 on a few different versions. In 1911, a French chemist called Stéphane Leduc wrote a book called Mechanisms of Life. In this book, he was basically trying to debunk the vitalist dream. So going back to what Venter is trying to debunk as well, through basically showing that life is merely a complex or series of complex chemical reactions, as we kind of heard today as well. So that was part of his larger debate you had with people like the creative evolution guy. Okay, come back. Anyway, it will come back to me maybe, if not, you good. Yes, thank you. Anyway, chapter 10 in this book from 1911 is titled Synthetic Biology. In this chapter, in 1911, he already says we know enough, or we soon will going to have enough knowledge about life that we can start to synthesize it. 1911 didn't even know what the structure of DNA is. They didn't even know what function DNA operates on. We are still in the same case. He did one of the experiments, the simple experiments he did was to build, to basically mix 2 salt solutions and ink. This is his 1911 version. This is a 2014 version, where we basically used a 3D printer that we hacked as a dripping machine, and we basically automated this 1911 protocol where you create stuff that actually looks like tissue, like cells. The problem is that after about 20 minutes, it becomes this pile or this basically collection of murky water, which I would claim, if we're honest enough, this is where we are at the moment. Thank you very much.